Hello, my name is Timy Phan. I'm an undergrad student at the Munich University of Applied Sciences in the Department of Computer Science and Mathematics. In this video, I want to motivate my paper, Searching with Opponent Awareness. Let's start with the basics of agent-based systems. In a single agent system, there's one agent and its environment. An agent can affect its environment by choosing one action out of multiple actions at each time step. An agent can also receive feedback from its environment in the form of state observations and reward signals. The goal of an agent is to optimize its reward signals through its choice of actions. So why do we need opponent awareness? In a multi-agent system, there are multiple agents, and every agent can choose its own action and receive its own reward signal at every time step. Without opponent awareness, an agent only tries to optimize its own reward signal. So this is an example of a suboptimal global state in a multi-agent system. In this case, autonomous driving, and the shared resource is the street, and the suboptimal state is a traffic jam. This can occur when every agent tries to optimize its own reward, for example by reaching the destination as fast as possible. Part of the reason why this happens is because agents consider each other static elements of the environment and not dynamic. They do not know that another agent has its own goals. This knowledge is what we call opponent awareness. The purpose of using opponent awareness is to improve social welfare and to avoid suboptimal global states like traffic jams. So now I will present the main idea behind searching with opponent awareness. First, I develop a gradient-based bandit, or grab bandit, which is enhanced with learning with opponent learning awareness, or LOLA. The complete formulation of the gradient-based bandit is also given in An Introduction to Reinforcement Learning by Richard Sutton, and learning with opponent learning awareness was introduced by First AR in 2018. Then, this new opponent-aware multi-armed bandit is applied as a selection strategy in Monte Carlo tree search, or MCTS. This version is also called Searching with Opponent Awareness, or SOA. So to sum up my contributions, there is an opponent-aware gradient-based multi-armed bandit. Then this new bandit is applied in a decentralized MCTS. In other words, every agent runs MCTS on their own. Finally, this new planning method is compared to other existing approaches in different domains and evaluated according to their performance and also their social behavior. One of these evaluation domains is coin game, where there are two colors, red or blue, and one agent for each color. There are also coins, which can have either color, and if an agent picks up any coin by moving to its position, it receives a reward of +1. However, if a blue agent picks up a red coin, then the red agent will be penalized with -2, and also the other way around. Now, here I'm showing you a few results from my experiments where I compared SOA, my proposed approach, with MCTS using different bandits, like gradient-based bandits and UCB1 bandits. MCTS with UCB1 bandits is also known as UCT, which is why I'm listing it as UCT here. So on the left, you can see a plot where I'm showing the probability that an agent picks up a coin of the same color as the agent in CoinGame. And the MCTS using grab and UCB1 bandits always results in a probability of about 50%, which is a greedy policy because they pick up coins of any color as long as the coin is within their reach. And Zoa always results in a higher probability that a blue agent picks up a blue coin or a red agent picks up a red coin. This is also shown in their collective return, which is higher for Zoa because an agent is less likely to be penalized because the other agent picked up their coin. Like the red agent is less likely to be penalized because the blue agent is less likely to pick up the red coin. So, and that's why the collective return is higher. Okay, so I hope you enjoyed the video. Thanks for watching it. And if you have any more questions, I'll be happy to answer them. And more details are, of course, available in my paper.